Hi, sorry about taking so long. So I'm gonna do number 38, and that one is the square root of 7x to the sixth. So I think a really important part of understanding this is realizing how a square root, just like square root in general, is represented as an exponent. And so the way that is a square root, I'll do that in blue, like just a square root normally, x, right? Or let's just say, yeah, x. This is the same thing as saying x to the 1/2. And then where did those, like the 1/2 and that come from? So there's a 1 right here, that's this one, and there's actually a 2 written right here, and that's this 2. So then when we see this, that's the same thing as saying x to the 1/3. Like this 1 is right here. There's technically an invisible 1 there, but x to the 1 is just x, so we don't write that in, right? Sorry, we don't write that in. So then the 3 is here, so it's a cubed root, so it's really x to the 1/3. Now say we had, keep that cubed root, but now say we had x to 2. Remember how I said the 1 was right here? The 2 is here, right? So now we have x 2 thirds, x to the 2/3, sorry. And 3 is still there from there, and then squared. So say I had, technically, square root of x squared. There's technically a 2 here, right? And we got this first 2 from here. So I really have x 2 over 2, which is the same thing as x to the 1, which is just x. And if we take the square root of x, what do we get? Or square root of x squared, we get x, which is this. Okay, so just that's a little backup, just so you understand how I'm doing this, okay? So, first step is, what can you take out right away? So this is a square root of 7x to the 6th. Well, we know that the square root of x6 to the 6th is x cubed, right? Because x cubed times x cubed is the same thing as x to the 6th, because you add up when you multiply exponents. So we can pull out the x cubed, and then we still have 7. But we want it in exponent form, right? So, like we said, like I just told you, this is the same thing as saying to the 1/2. So the ultimate answer is going to be 7 to the 1/2. It doesn't matter. I don't know if he has you write the number first, but this is the final answer for 38. Okay, so let me do one more example in that. And this is still writing in exponent form when you are given a radical. So I'm gonna do number 30. I'm just gonna do number 39. So this is square root. Okay. And now this one's slightly different because it's 6a to the 12. Like it's not individually each to the 12. It's 6a as a group to the 12th. So for this one, what we're gonna do is we're gonna do 6a. So remember, I always do this to help me. So this is a square root. Technically the 1's here. So this is how we get the x to the 1/2, right? So this 12, this is there, and this is a square root, so there's technically a 2 there. So this is really 12 over 2. 6a grouped together, 12 to the 2. But we know fractions, right? So this is really 6a to the 6th. And now we can distribute this exponent. And now we get 6 to the 6th and 8 to the 6th. And then that's that answer. Since he says leave it in exponent form, I wouldn't simplify this down to 36, 8 to the 6th. And if he fights you on that, show him the answer key to this. Okay, so that's for going to exponent form. If we're doing one from, I'm a little confused on how he's doing from exponent to radical because I'm getting different answers from him. So I'm not fully sure, and even the videos I've looked up, I think he's doing it in a specific way that I'm not entirely sure on that one. But I'm getting the right answers using this way from radical to exponent. So we're going to move on from that. Now I'm going to do like number 42. So x to the 7/18 times x to the 1/4. Okay, so when you multiply two numbers with exponents and they have the same base, the exponents are added to each other. And this one is really, you're just looking at these and you're adding, but now you really have to take into account that they are now fractions. So what do? You find a common denominator. So does 4 go into 18? No. But 18 times 2 is 36. Get 14. And then if I make this 36 by multiplying by 9, we get common denominator. And then I get 23 over 36. And then that's the final answer. Let's do 46. Sorry, I'm just writing it down. Okay. So this one, we already went over, like, remember I told you the first thing I want you to do is if there's an x on the top and there's an x on the bottom, or y on the top, y on the bottom, whatever, I want you to simplify it, simplify it to where there's only an x on either the top or the bottom. So remember how we did this first? What I would do first is there's two, like, they're both negatives. I would flip them so they're not negatives anymore. So what I mean by flip them is, well, x to the -2 on the bottom is going to be x to the 2 on the top, right? And then x to the -1/3 on the top is really going to be x to the 1/3 on the bottom, right? So that's what I would do first, get rid of the negatives. And then, remember when we have a numerator and denominator, x is to the exponent, we look at the bigger exponent and subtract the smaller exponent from the bigger exponent. And wherever the bigger exponent is, that's where your final variable with the exponent is going to end up. So let me explain that. We talked about this before, but just to reiterate. 2/5 is greater, actually, is 2/5 greater than 1/3? Yeah, 2/5 is greater than 1/3, because 2/5 is 0.4 and 1/3 is 0.3333, whatever. So this is the greater one, and this is the less one. We're going to do whatever is greater minus whatever's smaller, and we're going to get that number. So we're going to do 2/5 minus 1/3. Once again, common denominator, right? So the common denominator here is going to be 15. I'm just doing common denominator. So this one I'm multiplying by 3, and this one I'm multiplying by 5 on the top and the bottom. So now I'm left with 1/15, right? And like I said, we're going to put the x to our 1/15 wherever the greater exponent was, so that's going to be on the top. If you were to put it on the bottom, that'd be okay if you had it as a negative exponent. So now we're here. X to the 1/15 to the 15th, you're just going to get x, right? Because when you multiply, when you multiply exponents, when you do an exponent to the power of another exponent, you're going to end up multiplying them. So you just get x, and that's how you get that. And that's the final answer, 46. Yeah.